Sir, can we start? Greece, sir?
Yes, sir. Yes, sir. We can start.
Yeah. Very good evening to all. This is Faculty Development Program, AI for Industry 4.0, bridging academia and industry applications. Today is the 7th session in this series. So, welcome to you all. Now I would like to introduce today's expert, Dr. Sulakshna Arora. Sulakshna Arora is the CEO of Dextroids Inc. and is a seasoned cybersecurity expert with over 15 years of experience, holding certification in SIEM tools. Sulakshna has dedicated her career to protecting organizations from cyber threats. Her extensive background includes working with government agencies, Fortune 500 companies, and startups, providing her with a deep understanding of diverse cybersecurity challenges across various sectors. Sulakshna Arora possesses expertise in a wide range of cybersecurity domains, including threat intelligence, proficient in analyzing and interpreting threat intelligence data to identify emerging threats and vulnerabilities. Security architecture is skilled in designing and implementing robust security architectures to protect network system and data. Companies' compliance and governance well versed in regulatory compliance requirement and best practices ensuring clients meet industry standard and regulations. Through her career, Sulakshna Arora has achieved numerous accomplishments, including developing innovative security solutions to address emerging threats, earning recognition from industry peers and stakeholders, also successfully leading the implementation of enterprise-wide cybersecurity programs for multinational corporations, resulting in improved security posture and reduced risk. With over 15 years of experience, Sulakshna Arora is seasoned cybersecurity experts whose work has spanned government agencies. Her expertise extends across critical domains including threat intelligence, security architecture, incident response, compliance and governance, and security awareness training. Sulakshna Arora has consistently demonstrated her ability to analyze evolving threats, design resilient security frameworks, and lead large-scale cybersecurity initiatives. Among her notable accomplishments, she has developed innovative solutions to counter emerging cyber risk and led enterprise-wide cybersecurity programs that have strengthened security postures for multinational corporations. Her work has earned recognition from industry leaders and stakeholders like as CEO of Dextrise, Sulakshana Arora is driven by a powerful vision to empower organizations with the knowledge, tools, and expertise needed to defend themselves effectively in today's digital world. With her visionary leadership and commitment to excellence, she continues to advance the field of cybersecurity and help business operate with confidence and security. Please join me in welcoming Sulakshana Madam. Welcome.
Hi, good evening. Um, I'm sorry I'm having some technical problem with my camera. I think my camera is not working. But a very good evening to everyone, and thank you for being here today. Uh, I hope I'm audible. If you can please confirm, am I audible to everybody?
Yes, madam, you are audible, madam.
Okay, nice. Okay, thank you. Thank you so much for this opportunity to talk to all of you. I'm delighted to present before you the topic that I need to discuss here is fundamentally going to shape the future of engineering, manufacturing, and the career of many people. And the topic is AI for Industry 4.0 and how we bridge the critical gap between academic research and real world industrial applications. Very profound subject as we are heading towards self-reliance, right? The purpose that our leaders are focusing on. So over the next hour, we are going to explore three critical questions, which is going to be how is artificial intelligence transforming manufacturing today? What are the real tangible applications that are generating millions, sometimes billions in value? Second, what is the talent gap and why are companies desperate for engineers who can think differently? Third is going to be how can we, academia and industry together, build a bridge that connects cutting edge research with practical world changing solutions? Um, I am so this is these three things that we're going to cover in the next 1 hour. If anyone has any question, uh, either you can raise hand or we can take up at the end of the session. So this is not exactly going to be a theoretical session, not discussion. This is about the future, right? Whether as a faculty member who's designing the curriculum or a research pushing the boundaries of AI or a student preparing for a career in engineering, this conversation directly impacts all of us. Okay, can we move to second slide, please? Thank you. So this is about the fourth industrial revolution that we call 4.0. Basically, this is called so there have been industrial revolution, and we are not even, we're in between 4.0 and 5.0, but 4.0 has not been implemented properly everywhere. So let's focus on 4.0, and which is called the fourth industrial revolution. So let me set the context here. We are living through the fourth industrial revolution, what we call Industry 4.0, as I mentioned. The first industrial revolution brought us mechanization through water and steam power. The second gave us mass production and assembly lines. The third brought us computers and automation. What is the fourth? The fourth is fundamentally different. It's not about machines doing the work. It's about intelligent machine making decisions in real time. And when I say intelligent machines making decisions in real time, it means we are learning from the data and we're adapting to the change and optimizing themselves continuously. So here I would like to mention Klaus Schwab. He was the founder of the World Economic Forum, described this fourth revolution perfectly. And he mentioned that the fourth industrial revolution is characterized by a fusion of technologies that is blurring the lines between physical, digital, and biological spheres. Now, what does this mean in practically? It means manufacturing plant where sensors monitors every aspect of production, temperature, vibration, everything is working like 24/7, but and it is also generating the data at the same time. It means that it is analyzing the algorithm and the data is actually real, which is used to predict future actions, decisions are impacted basis the data that is being generated, collected, and analyzed. So, so what again? It is impacting our supply chain, which is definitely adapting to this disruption, this disruptive technology. It means quality control systems that catch defects invisible to the human eye, because we already have the data in place, right? Um, so we are looking back and checking and analyzing what has happened, and we are predicting the future. And this is again, we used to watch this in the sci-fi movies, right? But the time has actually come. We are actually in that era where all these factories, the modern factories that they used to show in the movies, are actually working and operational. So the critical insight is the companies leading this transformation aren't just investing in technology. They're investing in people. They're desperately searching for engineers who understand both the domain, mechanical systems, electrical networks, chemical process, and the new tools of artificial intelligence. So the opportunity for our youth who are in this field is humongous. Because there is a huge gap that exists between the technology and the people who know the technology. I hope it's clear to everyone. Any question?
Kindly ask any doubt. If any doubt, please.
Okay, thank you. Let's proceed to the third slide.
Okay, ma'am. Wait, please. Why it is not? It is not. Was Vinit sir?
Yes, sir.
Yeah, please try to, because my screen is hang now. So try to share the.
Can you stop the streaming from your side?
Yes, I am just trying to do that. Now it is visible or not?
Screen is visual. I think what not changing. Should I share?
Okay, I am na just living. Actually, मैं complete hanging. Therefore, I am living from the session. Okay, and you control from your side. Maybe possible. Is it okay now?
Well, let's
Yes.
see. I'm trying.
So can see the slide now. We can put in presentation.
Now this one.
So Laksana madam, kindly let me know which slide is required.
Slide 3,
Okay.
please.
Slide 3.
Okay, kindly you share, please. I am leaving the meeting.
This one is okay, no?
Yes, AI for industry. Perfect. AI for industry 4.0. All right. So, why is AI suddenly so critical? 3 reasons. First, there's data abundance. We now have more data than ever before. Every sensor, every transaction, every interactions generate data. In a modern manufacturing facility, you might have thousands of sensors generating terabytes of data every single day. So, what exactly this data is used for, right? Like the basic question is, we just keep listening, and I'm sure we all of us here are educated and we know how data works. So this data is now is very valuable, right? It is you can say that data is gold, but only if you can extract insights from it. So just collecting the data is not enough. If a machine is running, when it is going to break, it can be predicted. When the part needs to be replaced, it can be predicted. So all those information collection is critical, and also analyzing the data is critical, right? How to bring the data to use. So that's where we need AI. Second thing that we need AI is the computational power. Uh, the computing infrastructure to process this data has become affordable and accessible. Cloud platforms, GPUs, we are listening to the news every single day about NVIDIA and all. Distributed computing, these are no longer luxuries, and they are very handy nowadays, right? Any organization can now access the computational power that was once reserved for tech giants. So things which used to feel rare are coming to common people in various forms. Then the algorithm maturity. Now, machine learning algorithms have matured dramatically in a couple of years. We are not talking about experimental techniques anymore. We are talking about proven production ready algorithms that work reliably in real world conditions. Deep learning, reinforcement learning, time series forecasting, these are tools that engineers can deploy today. So we need our engineers to understand the meaning of these words. They're not words, how to use them, right? Um, like time series forecasting, for example, it helps in making sure that the machine's uh, history is recorded correctly. When you combine these 3 factors, we have data, which is abundant, we have a computational power, and we have mature algorithms. Now, imagine if you have these 3 important things at your hand, it is going to result in a transformation. And that transformation is happening across every industry. Uh, however, so as simple as it sounds, it's not that easy to happen, right? There are challenges. Um, the pace this transformation is happening at the upper level is outrunning our ability to educate the next generation of engineers, because um, curriculum doesn't change the way technology is changing. Um, our faculties, their training. So there are a lot of things that needs to fall in place to make sure that our students or the next generation is in line with the changes which are happening, right? So that is the practical challenge. However, there's a need, there's a demand, but there's a gap of the actual trained resources in the market, because industries are willing to invest in the latest technology, but they need people to operate. Machines won't run on their own. I mean, I know that there is a fear that machines are going to take our job, but we need to understand that machines are not actually taking a job. It's just forcing us to become more intelligent. They're taking the jobs which are redundant, which can be done by anybody. So we have to force ourselves to become smarter than machines so we can use the machines, and machine stays beneath us still. And it is actually possible. It's just we have to change our focus and start studying what is new in the market, like study, in the technology. So companies are hiring AI specialists, data scientists, machine learning engineers, and if you look at the um, job portals, their jobs are these designations are quite in demand. But they're not just looking for computer scientists. They're looking for mechanical engineers who understand AI, electrical engineers who can deploy machine learning models, chemical engineers who can optimize processes with reinforcement learning. So they are basically looking for T-shaped engineers, and which we are not producing in I think large quantity. Um, can we move to the fourth slide, please? It is the case study.
Is it all right? From my side, I have changed the slide.
Oh, I still see the first slide for some reason.
I have changed in my display. It is different. Here it's showing AI in action, resilient supply chain.
Yeah. Okay. I think the slides can be shared with the team uh, later, right? Let me just uh, share what I want to talk about in the next slide. Next slide is basically it's a case study for predictive maintenance. I just mentioned the T-shaped engineers, right? Um,
I'm trying again.
May I try, sir, from my side?
Let me try it.
Okay.
you might want to cross it and reopen the presentation. Let me move ahead with the what predictive maintenance is. Um, So the predictive maintenance is one of the most impactful AI applications in manufacturing today. Um, Imagine you're running a large manufacturing facility. You have expensive equipment, right? Like pumps, motors, compressors, turbines. When one of these faults unexpectedly, it's catastrophic. Um, your business is going to be impacted because there is a whole supply chain and the whole process which is which will be disturbed. So production will stop, orders miss deadlines, customers will not get their orders on time, they will be angry, and the repair cost. So as the owner of that of the manufacturing unit, you are going to incur a lot of loss, and also your name, the goodwill that you have created, will be tainted. Tens of thousands, sometimes hundreds of thousands of dollars, or in money, in Indian currency. Now compare these two approaches, right? Let's have two approach now. Reactive maintenance, where you wait for things to break, where one fine day somebody reports that the machine has stopped working, versus preventive maintenance, where you replace parts of a fixed schedule on a fixed schedule, depending on the machine's runtime, right? For example, whether they need it or not, but again, that's going to be wasteful. I mean, my machine is still running. I know you gave me 10,000 hours to run, but my machine is still running. So why should I spend money on something which is not broken, right? If you're doing a business, if somebody's doing a business, they will think that way. Now, there has to be a middle ground where I am not wasting my money for being over proactive, and also I'm not reactive where I'm impacting my productivity. That's where the AI will come in the picture. Um, how about we can predict the failure before it happens? What if you avoid tell what if you can tell that your maintenance team can come up with the analysis that says that uh, this machine is going to fall in 72 hours, and let me tell you, this is not theory, this is practical. This can happen, and that's where we need AI. So there's something called scheduled maintenance that can be scheduled on the weekend when the productivity is not happening, when the machines are not running, or you can have a downtime, assigned downtime. This is called productive maintenance. How it works is we install sensors on critical equipment. These sensors measure vibration, temperature, acoustic emissions, and other parameters, and then they send data continuously to a central system. Machine learning algorithm, as we discussed. Sorry, anyone has any question? Okay, as we discussed the machine learning algorithm, right? So, we are collecting the data. We have the algorithm in place, and we are collecting the data, and we are using the data basically to do that predictive analysis that we were discussing. Uh, Now this is happening in real time. I'm sorry, I hear echo. May I request everyone to be on mute, please?
We are getting echo, madam. Madam, kindly unmute your mic.
I'm sorry. Am I audible?
Yes,
Yes, madam.
yes, audible.
Audible.
Okay. Till what part did you hear me talking? Okay, let me repeat it again. I was talking about predictive maintenance, and I just mentioned that how we collect the data from the machine, and we analyze. We can predict that at a certain behavior that the machine is showing, we can, again, a lot of data collaboration happening, and there's a model that can be created that says that can say that if the rate of the machine is this much, it's making this kind of noise, then the machine might stop working in, say, 48 or in 72 hours, and hence get an alert, get alerted, schedule a maintenance, call the people who can come and fix the issue in advance. That ways, you're not wasting money by assuming that the machine has aged, and you are spending a hell lot of money to get the parts changed or waiting for it to break. Okay. So the result is dramatic. Companies implementing predictive maintenance, they see 40-50% reduction in unplanned downtime, which means the production is running when it has to be running. Extended equipment lifespan. That means instead of replacing parts on a fixed schedule, you replace them only when necessary. Optimized maintenance scheduling. That means team can plan their work efficiently without emergency callouts, and a lot of labor issues can be handled that ways. Your company is running smoothly, and millions in cost savings. So a large facility which can translate tens of millions annually can actually be benefited with this kind of planned, informed decisions. Now the critical part is building these systems requires both domain expertise and AI expertise. Uh, Dr. Vineet, I think if you can please go on mute.
Mm.
Okay. So to build these kind of expertise, we need so to build this kind of system, we need the expertise and the domain expertise, right? Um, Therefore, we need the engineers. That's where we have to bridge the gap. We need the engineers who understand mechanics, vibration analysis, equipment design, and also they need to know the AI and the modeling. So time series forecasting, anomaly detection, and how to deploy machine learning models in production environments. This is so the amalgamation of all these things is called T-shaped engineering. And we need those T-shaped engineers who know this T-shaped kind of knowledge um, for the companies to hire. Sorry for the interruptions. I know it just breaks the flow, but let's move ahead to the slide 5, please. Slide 5, quality control. Now, how AI can impact the quality control. In manufacturing, quality is everything, right? If a batch is defected, the entire it can incur a lot of loss to the company. a defect that reaches a customer can cost that customer forever. It can trigger recalls, lawsuits, and regulatory actions. So companies invest heavily in quality control. Um, so as it has been happening, traditionally, quality inspectors examine products visually. They look for defects, cracks, discoloration. I'm not saying that all the companies are doing that, but uh, investing in a machine which is advanced, where no human intervention is needed, it's a big expense. So, but that's where the new machines, which are coming with the intelligence, where human get tired, human miss things, and human inspecting is slow, the machines can take over. So machines are going to take over that kind of work. And we need people who can again manage those machines. In a high-speed production line, you might be producing hundreds of units per minute. You can inspect every single unit manually. So you sample, you inspect 5%, and you hope that the other 95% are good. Am I audible clearly?
Yes, madam, you are.
Say again, I'm sorry. Let me know if you have any audio issues from my side, please. Can I get a thumbs up that I'm audible?
Yes,
Yeah.
please proceed, madam.
Okay, thank you. Okay, so we have been just inspecting in batches, and we were hoping 95% or the remaining is just perfect. So we were doing sampling. Um, Now, as we have the technology in hand, why not check the 100%? What if you could catch every defect in real time at production speed? So the two words are very important. Identifying every defect in real time and at the production speed. That's what computer vision and deep learning enable. Here's the technology. You install high resolution cameras at critical points in the production line. These cameras capture images of every product. The images are fed into neural network, deep learning model trained to recognize defects. Right? Now, this has been a boom to the companies because they do not have complaints coming in. So a lot of there are a lot of manpower who's managing customer grievances is in check now, and they're more confident to sell their product. The CNN has been trained on thousands of images of good products and defective products. It has learned the visual signatures of different types of defects. Now, when it sees a new product, it can classify in milliseconds, good, defective. There are shortcomings because again, the images that has been provided to it, it recognize only those images. The results are remarkable though. Near perfect inspection rates. The system catches defects that human inspectors would miss. The speed in which the system operates at production speed, no slowdown, no bottleneck. Consistency. Unlike humans, the system doesn't get tired and distanced. It applies the same rigorous standard to every unit. In microchip manufacturing, this is critical. Defects might be macroscopic, visible only under magnification. A human inspector couldn't possibly catch them, but a computer vision system, it can. In complex assembly, where products have hundreds of components, a computer vision system can verify that every component is present, correctly positioned, and properly secured. Um, give me a second. So this requires both domain expertise and AI expertise. We need engineers who understand manufacturing process, quality standards, and what constitutes a defect. But we only need engineers who understand computer vision, deep learning, and how to deploy these systems reliably in production. So please pay attention to the words that I just used, which is deep learning, someone who understands computer vision, and they know how to deploy these systems reliably. So the hands-on practice, not just theory, is going to be critical. With this, I will conclude this slide. Any questions for me?
Participants kindly asked any query regarding today's session. Please ask.
No. So this is the slide that I was talking about. I just concluded that slide,
Okay.
which is about the quality control,
Right.
how AI is impacting the quality in industrialization 4.0. Like, see, as you can see, things are getting better and better for the production perspective. But again, we need more and more people who can work for these organizations, for these companies, to make use of the technology. And I think that's what we are discussing here. So we are trying to understand what industrialization 4.0 is bringing with us, and where the gap lies, and how we can bridge the gap with our academics, the changes that we should be focusing on going forward in our education pattern. So the next slide is the supply chain optimization. Let's talk about the effects uh, on the supply chain. The COVID-19 pandemic, right? It exposed the fundamental fragility in global supply chain. A factory shutdown is in one country rippled across the world. Shortages cascaded. I'm talking about, China was the biggest supplier, and everything fell apart, right? We saw prices soaring. A lot of things were not in the market. Companies which were thinking that they're resilient, they're stable, they realized that how things can get disrupted with one natural calamity. Since then, but one good thing is we are learning our lessons, and we are learning and we are evolving. So since then, companies have been asking, how can we build supply chains that are resilient? How can we anticipate disruptions and adapt before they cause damage? Again, the answer that we all are looking towards is AI. What is AI? How AI can help the supply chain? It optimizes work on 4 levels. The first level is, please pay attention to this. The first level is demand sensing. The very first thing is it starts demand and supply, right? So the traditional demand forecasting use historical data and statistical models, but these models assume the future will look like the past. They are brittle, and when something which happens extraordinary happens, like we saw the COVID, which was a pandemic, or the trade wars which are happening nowadays, shift in the consumer preferences, they fail. So the traditional approach to do the forecasting is very crippled. It's not foolproof. It doesn't comprise of the unknown information, right? AI-powered demand sensing use machine learning to predict market fluctuations with greater accuracy. It doesn't just look at historical sales data. It looks at social media, sentiment, news trends, economic indicators, competitor actions, and dozens of other signals. So it is holistic. It is not going to rely just on the company's sale history. It builds more nuanceical, dynamic picture of what demand will actually be or can be like, or can predict. So they're models, right? When it comes to AI, always we always think in models. Um, that models is fed with a lot of historical data from all the places, and we can get a lot of information depending on the scenario we are thinking can cause problem to us. So demand sensing is one of is the first point that we need to keep in mind that impact the supply chain. Second is the dynamic routing. Once you know that what demand will be, now you know how to get the products to consumer efficiently. Logistic is going to be the second thing. uh, Thousand of possible routes, but we always have to understand that there are risks involved. So reinforcement learning algorithm can optimize routing in real time. If the port is congested, the algorithm reroutes shipments. If weather delays a truck, the algorithm finds an alternative, just like GPS, right? Just to give a real world example. Um, if we see the fuel prices are rising, uh, the algorithm can actually adjust routes to minimize cost. So all these things, this intelligence it uh, can be brought through AI, because again, machines are working 24/7. They do not get tired, and they do make mistakes, but not the error that human being makes. Third is the risk mitigation. Supply chain are networks. A disruption of one mode can propagate through the network. AI can identify vulnerabilities in these networks. It can recommend alternate suppliers. It can suggest the routes. It can suggest the weather warning that weather is not right. Take another route. So you're saving time. You're not getting stuck. Your shipment is not getting stuck in the between the sea. So all these are designed to prevent cascading failures, right? Now, so we have covered how it can predict demand, how it can help us in the dynamic routing, and how it can mitigate the risk and the risk of unknown, and how it now the fourth point, again, the critical point is how the post-pandemic resilience has been built. The pandemic taught us that we need supply chain that can adapt autonomously to disruption. AI enables this. The system continuously monitors for anomalies. See, reading the anomaly is the key for resilient, anything to make resilient. And this data collection, and with the help of AI, has made a magical change in our entire, I should say, I don't know how to put it very easy in easy words, um, in our work infrastructure. So it adapts, it reroutes, it can help in uh, activate the contingency plans, and everything can happen in real time. So the impact is actually substantial. I'm concluding this slide, how AI can impact the supply chain. It reduces inventory waste, prevents stockouts. All these things are in the favor of the industrialists. Um, it can give the logistics that can cut the cost for delivery and shipments. It can mitigate the risk, like that can predict the interruptions, and it can be autonomous adaptation for enable 24/7 optimization without human intervention. For a global company, this can mean hundreds of millions in savings annually. But here is the engineering challenge. Now, the bottom line, where we're discussing about the academia and 4.0, building these systems requires expertise in operation research, reinforcement learning, network analysis, and systems engineering. I'm repeating: operations research, reinforcement learning, network analysis, and systems engineering. We need to understand both the domain supply logistics, procurement, distribution, and the AI technique that optimize these systems. Any questions? All right. Next, the talent gap. Are we keeping a check on time? Are we on time? Okay. The talent gap. I hope everyone is with me. Can I get a thumbs up? Thank you. Okay, the talent gap. What is talent gap? So we have seen these transformative applications of AI in manufacturing, predictive maintenance, quality control, supply chain optimization. Each one requires engineers who understand both their domain and AI. And here's the reality: we don't have enough of them. These are massive talent gap in the market right now. Companies are competing fiercely for AI talent. Salaries are actually skyrocketing, and yet with premium compensation, companies are not able to find enough qualified people because our educational system hasn't adapted. We have not been as quick in adapting what has changed in the technology, right? We're still producing specialists. We are producing mechanical engineers who know mechanical things but not AI. We are producing computer scientists who know algorithm but they don't know manufacturing. We are producing electrical engineers who understand circuits but not machine learning. So the key word for our future engineer is the T-shaped engineers, T-shaped engineering. So as you can, as just imagine the letter T, the alphabet T. The vertical bar represents the deep expertise in the specific domain: mechanical engineering, electrical engineering, chemical engineering. The horizontal bar represents broad knowledge across many disciplines: AI, machine learning, data analysis, cloud computing, and systems thinking. A T-shaped engineer can go deep into their domain. They understand the physics, the constraints, the real-world complexities, but they also understand AI. They can recognize where machine learning can add value. They can work with data scientists. They can deploy models that can think about systems holistically. These engineers are rare and they are high demand, but the industry is looking for more and more of them, and we are in short of such resources. If you look at the slide, there is called domain expertise. That means somebody who knows the domain, understand the domain deeply. Mechanical, electrical network, chemical processes. We need the data science skills, which means understanding of machine learning algorithms, statistical modeling, data analysis. So there has to be a perfect marriage between these topics in our education, in what we are teaching in our to our students. Machine learning operations and system integration, which means ability to deploy machine learning models in production, understanding of cloud platforms, DevOps practices, and how to integrate AI into complex systems. So the critical insight is going to be the shortage of T-shaped engineers, and it's actually not a temporary thing. It is structural. There's a lot of scope. Our people can actually be in demand. All they need to do is to upgrade themselves, learn what they're lacking. As long as our curriculum remain siloed, that will not happen. As long as mechanical engineering, computer science, and data science are separate departments with separate courses, we will continue to produce specialists, not T-shaped engineers. So the demand of the hour is of the T-shaped engineers, which is going to be a perfect amalgamation of all these resources, of all these of all these knowledge sectors that we have just discussed. So this is basically the biggest challenge that we need to address. Yes, we can move to the next slide, please. These are all the points that we discussed. Next slide. I'm sorry. Can you move back to the other slide, the previous slide? Yep. Curriculum shift. So I already mentioned a bit about it in our previous slide that these three subjects that we are teaching cannot stay in silo. We need to come up with a combination where all these three are merged. How do we address this? We have to evolve our curriculum to produce T-shaped engineers. The answer is not to add more courses. It's not to create new AI for engineers, but it's to, and the answer is integration. We need to fundamentally rethink how we teach engineering. First, we need to integrate AI and data literacy across all disciplines. And I hope uh, with this knowledgeable audience that we have here, they can actually they can actually draw some parallels to what I'm trying to put across. If there is no integration in the AI and data literacy across all disciplines, uh, it's going to be catastrophic. Instead of having AI as an isolated course in the computer science department, we need to weave AI concept into mechanical engineering as well, electrical, chemical, and mechanical. All engineers should know AI because AI is going to be a part of all our each and every life, whether you're working or not working. And if you're working, you cannot ignore AI. When students learn about control systems, they should learn about both classical control theory and machine learning based control as well. When they learn about materials, they should learn about machine learning can predict material properties. Not very big changes, I should say, but yes, a little mindful change in the curriculum. Um, we have to teach systems thinking. Engineers need to understand how their domain fits into larger systems. A mechanical engineer designing a pump needs to understand how that pump connects to sensor, to data pipeline, to cloud systems, to decision-making algorithms. They need to see the whole picture. Like we have a life cycle, SDLC, when we create an app or we create a software, same way things are changing for our engineers. They have to look into the entire life cycle, and the life cycle has 2 3 more steps in it. They need to understand the importance and draw the connecting lines between the changes which are coming in. Then we have to emphasize the real world problem. We have to we have to give them the practical information about what is happening in the industry. Textbook problems are important for building fundamental, but if they do not grapple with real industrial challenge, they are not going to be successful. They need access to the real data, and we have that information available. The thing is, we have ample information available. It's just we need to channelize all that knowledge in our students' curriculum, in their daily life, so they become better and better every single day. Then there is pause, and this problem is not just in India. I'm sorry, but this is universal. The way things are changing is is humongous. It's not easy lift to change every single day, but and we also have to motivate our students to have that desire to learn by themselves, keep themselves updated, foster interdisciplinary collaboration, create opportunities for mechanical engineers to work with computer scientists, create projects where students from different disciplines collaborate. This is how T-shaped thinking develops. So we are not working in just silo. We are not sitting and thinking, okay, I am a mechanical engineer, that's not my work. What am I supposed to do with the AI? Not impacting me. So that mindset needs to be changed. That's why foster in this interdisciplinary collaboration. Engage industry as partners. Industry understands what skills are needed. Industry has real problems. Indian industry can provide mentorship, data, opportunities. If there would have been no problems, there would have been no such discoveries and no such improvements. Universities needs to partner with industry to ensure curriculum remain relevant. A very high, very ambitious scope, I should say, but I'm not sure how easy it is going to be. But if we can actually do that, we can reach out to the industries, and because they do maintain their sheets, we get data from there and see what where the problem is and how we can solve, how we can educate our students the real world problem, and you know how you can find a solution. That's how they teach in MIT, right? They give projects to the students, they have to come up with a solution on their own. Well, it's not easy. It requires faculty to step outside their comfort zone. It requires curriculum committee to make difficult decisions. It requires investment in new resources and new teaching approaches. But it's essential. The alternative is to continue producing graduates who are not ready for the jobs that exist. And here's the opportunity. Faculty who lead this transformative journey will be shaping the future of engineering education. You will be preparing students for careers that don't yet exist. You are contributing to research that solves the real world problem. You're building partnerships. And if you need any help, resources are available. So that is another challenge, right? Uh, but yes, this is how we have to make changes in our existing curriculum. Otherwise, the gap is going to be greater and greater, and it'll be very difficult to build the bridge between what is needed and what we are producing. Thank you. Can we move to the next slide, please? Research, solving the $100 million problem, $100 million problem. Are we, is everybody with me so far? Am I making sense? Thumbs up. Thank you. Okay. Now, let's try to look at the real world problem now, right? This is not the curriculum. This is like critical area, which is research. Academic research is where breakthroughs happen. It's where we push the boundaries of what's possible, but academic research often operates in isolation from industry. The point we just touched before this. If we can go to the industries and ask for the real-time problem. Researchers publish papers that are read by the researchers. The insights are valuable, but they may not translate into practical impact. What if we could change that? What if academic research was directly informed by real industrial challenges? Consider this. A company has a problem. They're losing millions annually to equipment failures. I am keeping it consistent. So we have muscle memory, right? We just talk about the failure of a machine. And so we are continuing with that. So company is losing millions because there is an equipment failure. They have tried everything, traditional predictive maintenance, rule-based systems, nothing works well enough. They reach out to a university. They say, we have real data. We have a real problem. Can you help us? The researcher takes on this challenge. They work with the company's engineers. They access real data from real equipment. They develop novel machine. So they basically develop the approaches which are novel in nature, right? Which is like first-hand thought process and the solutions. They are testing them in the production. They're iterating it and they are coming up with a lot of solution. They're taking notes. They are documenting everything. As many times they're failing, they are documented. Now, what is coming out as a solution is the company's real world problem. We are not doing anything hypothetical. We are solving the real world problem. We are helping ourselves, we are helping the company, and we are building the real solutions. And those solutions can help. We are also machine in a way. We are also generative AI. We are becoming intelligent. It's just that we are inputting real and the actual problem. New algorithm, new understanding, how machine learning can be applied to the domain. The researcher published papers. Other companies adopt the approach. The research has impact at scale. Now, this is the problem. This is the power of industry-informed research. I honestly don't know how much is happening in the Indian scenario where we are actually handling situations or doing research that ways. If it is not happening, then I would encourage that is the right approach. That's mindful. But it requires different mindset. It requires researchers to engage with industry. It requires industry to be willing to share data and problem. It requires clear agreement about intelligent property, publication rights, and commercialization. When the conditions are met, the results are extraordinary. Research becomes more impactful, students get exposed to real problems, companies get access to cutting edge expertise. Everyone wins. This is what we mean by bridging academia and industry. We can move to the next slide. The imperative for collaboration. Any idea what we are going to cover in this? There's a famous saying that if you want to go fast, go slow. Sorry, if you want to go fast, go alone. But if you want to go far, you go together, right? So that's where the word collaboration is coming in the picture. We have, if we really want to go, keep these things moving, keep the momentum going, we need to collaborate. And that's what we're going to discuss. We are going to see how academia, industry have complementary strengths. Neither sector alone can address the challenges of the industry 4.0/5.0 is bringing. So 4.0 is not just sticking to the new machines, machinery, the data is generating, it's also going to the security perspective, the cyber security, right? We'll cover that. Now, what does industry bring to the table? As we discussed in the previous two slides, industries bring us. Okay, so industry brings data. I hope everyone is paying attention to this. Okay, industry brings data, real world data sets from production systems, sensor networks, operational processes. This data is invaluable. This is the foundation of training machine learning models that actually work in practice, right? The machines are working. And we are getting the data from the industries. Industries bringing the context, the real world problem. They're giving us understanding how industry, what are the industrial constraints, what is the business requirement, what is the operational realities. Researcher might develop an algorithm that's theoretically perfect, but practically impossible to implement, right? Theorem. I can create something. This production system, there's going to be a line, and then there's going to be 1,000 cameras capturing everything, and then have you thought about the what about the electricity is gone, right? The challenges, like I'm just giving some random example, but I'm just saying that when you are sitting with the people who are working at the ground, listening from them and collecting their problem is what brings the real problem, and the textbook knowledge is out of the window. Real challenges, what millions of cost savings and revenue generation. These problems drive research that has genuine impact. So basically, whatever we are working is going to be useful, meaningful, and not just filling the papers. So what does the academia bring to the table? Industries bring all these things. They're bringing real-time problem. They're bringing us um, experience where they're failing or whatever the problem is. Now, what is academia doing? Academia brings fundamental research, rigorous scientific investigation, peer review, the advancement of theoretical knowledge. This is where breakthrough happens. Academia brings talent, highly trained engineers. That's what we are. We should. That's what we should aim for. That's how we can actually handle this fear of losing job to the AI. We have to get more and more trained, and we need to produce more engineers who are trained. We need researchers who are looking at the problems, which are real world problem. Students who are eager to learn and contribute. Faculty who are at the frontier of knowledge. Academia brings cutting edge solutions. We bring algorithm, methodologies, technologies developed at the frontier of knowledge. Remember, we have a lot of experience. We have experience from the past, and we are collaborating. These solutions often come from academia before they are adopted by industry. When these trends combine, something powerful happens. Industry's real-world problems drives academic research. Academic research produces solutions that industry can deploy. Students can expose to both rigorous science and practical applications. Faculty get access to real data and real problems. Win-win situation, right? I have a problem, I have somebody who can give me a real solution. A perfect marriage. Companies get access to cutting-edge expertise. This is not a one-way relationship. It is not industry extracting values from academia. It's a symbiotic partnership where both parties contribute and parties benefit. So this is essential for building the future of Industry 4.0. We're nearing to the end. I am again asking, everybody is with me and they're understanding that the point is coming across as expected. I am expecting. So can we move to the next slide, please? Joint research labs. I'm trying to give an example how the collaboration model can work here. Do we actually build these partnerships? Let me outline 3 proven collaboration models. First is the joint research labs and centers. And here's how it works. An industry partner identifies a strategic research area. They partner with a university. Together, they establish a dedicated research lab on the university campus. The industry partner co-funds the lab. University provides space, infrastructure, and faculty expertise. Lab has a specific focus. It's advanced robotics, it's an industrial cybersecurity, maybe it's AI-powered quality control. The lab brings together faculty, graduate students, industry engineers. They work on problems that matter to the industry partner, but they do so with academic rigor. Now, what are the benefits of this? Can anyone suggest what are the benefits for this? Okay. So what happens? So we are bringing intelligence, resources, and a real world problem on the same table. Is going to bring the intellectual, build the we are sharing the intellectual property. We have clear IP agreements that enable both the parties to benefit from innovation. The companies can commercialize discoveries, researchers can publish academic journals, both can advance their missions. Then we have co-supervised PhD students. PhD research directly addresses industry-defined problems. Students grades with both academic rigor and practical industrial experience. They become bridges between academia and industry. Are we good here? All right. So this is the one-way relationship. Any questions? Okay, let me cover one more part, the impact. So the impact of this model is going to be stability and depth for faculty research. All the dignified researchers and faculty, they can make their work more and more impactful and useful. It transforms universities from knowledge consumers into innovation engines that solve real industrial problems while advancing the state of the art. I think I mentioned MIT earlier, right? MIT is a big example of that kind of approach. And that's why MIT is MIT. MIT is not theoretical. MIT is very, very real. It's practical. They they open the world to the students. They open their mind. They ask them to come up with projects. The students, they build up startup, they come up with startup ideas to which venture capitalists, they come, listen, and actually they pick up the ideas and sometimes they turn out to be a big businesses. So the only difference between how we are operating versus how MIT operate is they open the resources to the people who know how to use the resources, and the people who have problem, they take advantage of these intelligence. That's how MIT is MIT, and we all just keep thinking to get registered to that college, that university, right? Now, my second model for collaboration is the capstone projects and internships. Can we move to model 2, please? This is the most accessible collaboration model. It doesn't require massive infrastructure investment. Faculty can implement it immediately with existing capstone courses and internship programs. How it functions? Industry partner approaches a university. They have a real problem they need to be solved. They propose sponsoring a capstone project. A team of senior engineering students works on the problem over a semester. The company provides mentorship, data, and technical guidance. At the end, the students deliver a solution. Or alternatively, students intern at the company during the summer. The very generic model that we follow. They work on real projects with real data, but they are working in the once the course is finished, once the semester is finished, then they are going and handling the situations. So it's kind of reverse than how it should be. Uh, there are certain advantages to this for the students because they get real industrial data. They still not solving any toy problem. They are not doing any textbook thing because they're in real world, right? Working with a company. Though, so they build their own portfolio, and that can be used for them for the future employment purposes. Then we have faculty. You get to manage a project in the real impact. You ensure academic rigor with while delivering practical value. And you're also building relationships. You have the partner, you have the students, and you can keep your curriculum relevant, get some information. How it is helpful for the industry? You get access to fresh perspective and innovative solution. You get to scout talent, internship on capstone project is essentially extended interview, right? Yeah, this model is immediately tenable. Are we good? If you're good with model 2, which is pretty understandable by everybody, I guess, industry standard, we can move to the model 3. Thank you. Okay. So the model 3 is the faculty and industry exchanges. This model focuses on knowledge transfer and cross-pollination. Faculty sabbaticals in industry. A faculty member takes some semester or full year sabbatical instead of taking a break. They embed themselves in a major manufacturing plant or technology company. They work alongside industry engineers. They see how products are designed, manufactured, and optimized. They access the production data. They understand industrial constraints and timelines. They build networks with practitioners. When they return to campus, they are transformed. Their curriculum is immediately relevant to industry needs. Their research is grounded in practical problems. They become industry ambassadors, you can say, right? And they can tell students, here's what it's really like in industry. Here's what matters. Here's what you need to learn. For the campus, it is beneficial for the campus because you have the experts on the campus itself. Industry data scientists, engineers, leaders, tech specialized courses on campus. They bring real world experience into the classroom, and student can learn the cutting edge technology with all the talents in the real time. The impact. So the the model is actually going to help the people and relationships. It's about building mutual understanding and trust between academia and industry. Next slide, please. I think we can stop the slide. It's just the reference, like what we can do next. What I can say in the end is we have 3 proven collaboration models. Each has different characteristics. Joint research labs require significant investment but provide deep long-term partnerships. Capstone projects, and in terms of the second model, are immediately implementable and provide talent pipeline benefits. Faculty exchange facilitate knowledge and transfer the curriculum relevance. The question is not which model is best, the answer is all of them. Different institutions with who can prioritize differently based on their resources and strategic goals, but all 3 models should be part of the ecosystem. The critical point is the time for theoretical discussion is over. The time is for action, and that action needs to be taken now, right? So for the faculty, I would like to say, you are the architects of the future. Your decisions about curriculum, about research partnerships, about how you teach, these decisions will shape an entire generation of engineers. So you're as remarkable and as needed as has been from years, right? We all needed gurus. So you are the gurus. You are shaping the next generation. Now, how the help, I understand that faculty needs help as well. You need training material, you need resources. So teach the trainer thing is also very important. It should be in place. Then how we have to evolve the curriculum. We don't have to add this AI course and say, oh, okay, it's done. Just because we have AI word in our curriculum, it's done. No, we need to do a very thorough research and only implement what is needed for that group of engineers, right? Mechanical needs what, engineering needs what, electrical needs what. And it should be a thought process. This should not be cut and paste. It should be cut, edit and paste, copy, edit and paste. And let's be a catalyst in the change, lead curriculum reviews, propose interdisciplinary projects. If it is not happening at the higher level, at least have, the faculty talk among themselves and they try to mingle the projects, try to bring 2 different streams together so the students can get benefit. Champion the shift toward Industry 4.0 ready education. This is your opportunity to shape the future of engineering education. And seek out partnerships, reach out to the industries, look for labs, and get more and more companies involved with your institution and see if they can help. They can help bring their resources and you bring your students and your lab and see if you can come up with a greater solution and market ready solution, I should say. And inform the future, please. Your research must inform the next generation of industrial AI systems. Don't solve just the theoretical problems. Solve the 100 million problem. That means the problem of the industry, the problem that matters to companies, the problem that will have real impact. We have students. So to the students, please try to focus on as I mentioned, the T-shape engineering. If you are not getting help from the curriculum side, educate yourself. There's so much information available. YouTube is the biggest place of information. Um, get get a computer, shake hands with a computer scientist and ask them questions, study on it together. Develop a deep expertise in your domain. Be a domain expert, and also expand your knowledge. That is going to be a lethal combination. You will not be replaceable. Trust me, people are going to come after you to hire you rather than you thinking will not get job. Um, get hands-on with real data. Try to reach, be shameless, reach out to the industries, tell them that you need this. And sooner or later, they will also see an opportunity. See, they're businessmen. They see the opportunity that they're getting solution for free. Excuse me. Learn the tools and embrace complexity. I have concluded. If anyone have any question, please let me know.
तरी 180 से स्टार्टिंग प्राइस असतं 180 से लेके 550
Yeah, hi. I'm done with my presentation. If there are any questions, I'll be happy to answer them for you. All right, I think silence is golden, and I'll be happy if anybody wants to get in touch with me, any questions for later. Um, if I can be of help for anyone, please reach out. I'll be happy to talk and collaborate. Would like to be instrumental in actually this is a very we are sitting at a place which is going to shape the future. Trust me, in a couple of years we're going to see a lot of changes. um we have we have won in our computer revolution, right? We produce most of the computer engineers, and that's why we saw growth in India. I think this is the time when we start focusing on AI, machine learning as well. It's again a crucial turning point for the entire world. And if we are not running the race, we can be left behind. And I think our students are pretty ambitious. They're hardworking and they understand the importance of knowledge. So I wish everybody all the best, and really nice to I'm happy to be able to share my knowledge with all of you here, all the um, respected members. Thank you.
Dear participants, thank you, Madam Lakshana. The next speaker of this session is also Dr. Lakshana. So we will have some break of 15 minutes. Please join after 15 minutes.
I would like to make one correction here. I'm not doctor, so
Oh,
um,
engineer, sorry, engineer Lakshana.
sorry. Yeah.
So she will join after 15 minutes. Kindly, you can also take the break for 15 minutes. Please join after that.
Thank you.
Thank you.
Vinny sir, am I audible?
You are audible, Professor.
Yeah. Same PPT sharing now? This one, other
This
one.
is another one. Another one.
Okay.
Yeah, this one.
So, dear all participants, welcome back. Now, second session will be start soon. And Dr. Sulakshana Arora will be continue for her second session. Over to Dr. Sulakshana Arora.
I am not the doctor. Please.
Easy.
विनीत सर आपकी जो वॉइस है ना वो इको हो रही है काइंडली चेक
So do we have different panel or the panel continues? Same students, same participants?
यू कैन प्रोसीड मैम प्लीज
No, my question is, सब
Yeah.
वही हैं, सारे participants वही हैं या फिर
हाँ सेम पार्टिसिपेंट्स मैम सेम
okay. So again, I'm sorry, the slides are again in smaller font size. हम आपके साथ slide share कर देंगे. So please
Yes.
bear with that. Yeah, if pay attention to what I'm saying. Any question, please let me know.
Okay.
Good. Thumbs up.
Yeah.
Please participate. All right.
All right, ma'am.
Now this is security. Security is something that I'm very excited to talk about. I have spent like last 2 decades working at the intersection of cybersecurity, artificial intelligence recently. I have led security initiatives at major tech companies to advise organizations. And now we are also imbibing AI security strategy in that. Today, I want to talk about something that keeps me awake at night, the security of artificial intelligence systems. I am not alone in this concern. Every week, we see new headlines about AI vulnerabilities, data breaches, emerging threats that we didn't even know existed 6 months ago. Every day is a new day, honestly speaking. Every day you get, see new news, somebody hacked, new vulnerability came in the picture. Google, like all the big companies, they are coming up with so many loopholes. And more than us is the hackers who are using the AI for hacking, right? they are actually using ChatGPT to use to run the entire hacking module. So it's an amazing world. Trust me, it's more like it's more like that video game where there's a police and there's a good cop and there's a bad cop. You know, so many things happening here. Now, for this particular presentation, the question I want to pose is how many of you are actively working on AI security in your research or studying? If I can get hands up or can get the count. If nobody, it's okay. Okay. I will see. Okay. So if your hands went up and I did not see, I'm sorry, you're part of the growing community. If you didn't, I hope by the end of the session, you will understand why you should be thinking about it. So AI security is not a luxury, it is a necessity, and it's everyone's responsibility. We can move to the second slide, actually. Font is very small. I'm sorry.
Madam,
You
this
can
is
change
second
it to the
slide.
presentation. You can
Yeah.
change it to presentation mode at the right end corner. You see the presentation icon. It won't do magic, but at least it'll be better.
Yes, madam. Second slide is in the screen now, visible.
You can actually put it in the presentation mode. At the right hand corner. Yeah. Thank you.
Actually, system is getting hanged.
No worries. All right. Okay. Let's just continue. So you have to listen to me. Okay. It's basically the why AI matters now. So let me set the context. We are living through the as we discussed, right? Fourth industrial revolution. Now, unlike previous industrial revolutions that were driven by steam, electricity, computing, this one is driven by artificial intelligence and data. The numbers are staggering. Global AI market, and it is projected to reach like 1.8 trillion by 2030. It's lot of money that we're talking about. AI adoption in enterprises, it has grown manifold, right? 20%, 27 in 2000. And yeah, just to begin with, AI is not a new term. AI, this term has been coined in 1930. And there have been people who are working on it in entire life they have dedicated for AI. It's just that we are coming to know about it because, you know, we are getting the UI of AI. So user interface, ChatGPT, Perplexity, right? Copilot. So for us, that is AI. There are various use of AI, and it has been there for a long time. I'm sure we all must have heard about it multiple times. Like when you go to YouTube, you see the recommendation. Why? Why certain recommendation is for you? However, when I log in with my login, my recommendations are different because it is using AI in the back end. It knows my search history. It knows what kind of videos I like to watch. I watch news, so it'll give me recommendation of news, US news, Canadian news, BBC, right? I watch videos on AI, so I get all the upcoming talks, which is or the latest talks. My mom, when she goes to her YouTube, she sees a lot of bhajans. Why? Because there is an AI working in the background. So it is not new. We are listening just because it is in the bubble thing that is happening. So we'll cover all those things. But yeah, we all have adopted AI. Now it is something that we are in the know and we know and we can see it's happening. So in enterprise growth, is 20% in 2017 to 55% in 2023. AI-powered systems make critical decisions, healthcare, finance, autonomous vehicles, national security, all are taking benefits of AI. The critical part is AI becomes more powerful and more pervasive. So do the risks, right? A single vulnerability in a widely used AI model can affect millions of systems simultaneously. Um, data poisoning attacks on medical AI could result in misdiagnosis and loss of life. Adversarial attack on an autonomous vehicle could cause accidents. Model extraction could enable competitors to steal proprietary algorithm worth millions, right? Suppose there's a life science company and their secret sauce is stolen. So there are humongous benefits, but then again, we always have threats associated to it, right? It is exposed to the internet, the chances of attacks. The stakes have never been higher. In the past, security was often an afterthought, something you added after building the system. With AI, that approach is catastrophic. Security must be built in from the very beginning at every level of system architecture. So AI security is not optional. It's foundational to trustworthy AI systems. So when I say it is important at that point, it means when you're planning, suppose you're creating an app, and that app should have the security in place, right? Your code should be safe, should be secure. Next slide, please. The current state, AI transforming manufacturing. So let me give you a concrete example of why this matters. Manufacturing is being transformed by AI. Computer vision systems inspect products with 99.9% accuracy. Predictive maintenance algorithms prevent equipment failures before they happen. Supply chain optimization reduces cost by 15 to 20%. We cover all this. All the good things are happening. But then what keeps security professionals awake is the systems are vulnerable. In 2023, a major automotive manufacturer, they discovered that their AI-powered quality control system had been compromised through a supply chain attack. How many of us understand supply chain attack here? No worries. So supply chain attack is we collaborate with multiple vendors, right? I'm exposing myself to different companies. We are partnering with different companies. Every company is equally vulnerable to the attack. Now, for that company, I am the customer. Suppose I am using a payment gateway, and that payment gateway, they do not have their PCI DSS certification in place, or they get hacked and there's a ransomware attack on them. And all their customers' data is compromised. I am one of their customer. So I am compromised. So that is supply chain attack. And that's what happened with this manufacturing company. Attacker had injected malicious code in an open source library, and the company was using that source. That resulted in the AI system started systematically missing defects. None of them, just enough to avoid detection. 1,000 defective components made it to customers before the attack was discovered. Now, this is just one example. Similar things happen, similar vulnerabilities are happening every single day. And these can be catastrophic because we don't know. See, the main problem with AI is it's something that tells you very confidently, I know it. Whether it really knows it or not, it has the confidence. So we are trusting the model, we are trusting the result. Again, our organization has said, use this. Copilot has been given to you, use the Copilot. Now, if the Copilot is hacked, You may don't know it's happening at the back end. So this is the big challenge, fear of unknown. AI systems are complex, they are opaque, they are difficult to secure. Their traditional cybersecurity approaches don't work because AI introduce entirely new attack surfaces and threat models. So we need to be fundamentally, we need different approach than traditional cybersecurity. Sorry, nothing is visible here in the slide, yeah. So we're discussing the threat landscape. To understand the AI security, we need to understand the threat landscape. That means think of AI security threat as existing to your distinct levels. Is happening at a distinct level, each requiring different defenses. Data level threats, these are attacks on the training data itself. If you poison the data, you poison the model. Foundational. Model level threats. There are attacks at the AI model itself. Adversarial example, model extraction, backdoors. These attacks happen after the model is trained, but before or during the deployment. Now, this is insider threat. Someone in the organization is who has access to the data model is actually corrupting the data model. Deployment level threats. These are attacks on the infrastructure where the model runs. Code injection, weight manipulation, compromised dependencies. These are infrastructure security issues specific to AI. I'm again repeating, code injection, weight manipulation, compromised dependencies. These three are infrastructure security issues which AI face, and they are deployment level threats. And the fourth one is the operational level threat. These are organizational and procedural vulnerabilities, poor monitoring, weak incident response, insider threats. These are the human factors, right? So the biggest propagator to develop AI was we figured that human is the weakest chain in the line of security, because machines, we can code, we can tell them do this, do this, do this. How a human, to err is human is true, and to eradicate that erring part, AI, people who supported AI, their belief became stronger and they kept going. That's the bottom line. So level 4 that I said, operational level threats, where the organization procedural vulnerabilities, poor monitoring, weak incident response, insider threats are the human factors. Here's the now what is the critical thing? Threats exist at every level. If you only defend at one level, you leave critical vulnerabilities exposed. You need a multi-layered defense strategy. Think it like think like a castle. If you only build strong walls but leave the gates unguarded, the walls don't matter, or for that matter, windows, right? Windows won't matter because they're open. An intruder can get inside your castle. If you only guard the gates but have weak walls, you're still vulnerable. You need defenses at every level. So the need for the comprehensive AI security requires addressing threats at all 4 levels simultaneously. I hope I am audible and you all are with me.
Yes, madam, you are audible.
Thank you. Let's move to the next slide, please. The first thing that we discussed, data level threats and privacy. There are 3 sections here. The first one is the data poisoning, right? So data poisoning is the most insidious attack. There are various reasons for that, like mislabeling attacks. An attacker introduce incorrectly labeled data into the training set. A medical so when I'm talking about AI, I don't know how many of us are aware about AI. Maybe I am the one who don't know much and you guys know more. I don't know, but for the explanation purpose, um, when we think about AI, we think about models, right? Um, so the training set through which we train the AI model, um, it gets impacted, it gets infected. So a medical AI trained or mislabeled X-ray, right, will learn to make systematic errors. If I am uploading wrong information, if I'm uploading wrong tray of X-rays with incorrect label, rather than say foot X-ray, I mention it to be hand X-ray. AI is learning from what I'm teaching, right? It can be purposeful, it can be a mistake, again, human mistake. That's a possibility. So mislabeling attack, it's a part of data poisoning. And second is the backdoor attack. An attacker introduces a hidden trigger into the training data. When the model encounters this trigger in production, it behaves in a specific way. For example, a backdoor is in a facial recognition system might cause it to always identify specific person or authorized regardless of who they actually are. You cannot identify it. It's very difficult. It's very difficult to figure out. Then the availability attacks is the third one. An attacker degrades overall model performance across all classes. This is harder to detect because there's no obvious pattern. The model just performs worse, and you are not able to figure out what's happening, what's wrong. It's like finding a needle in the hay. It's really that difficult. Then the targeted attacks. An attacker causes specific misclassification without degrading overall accuracy. This is most dangerous and is the hardest to detect. So again, data level threats and privacy in AI. The very first is the data poisoning. There are 4 kinds of data poisoning: mislabeling of attacks, backdoor attacks, availability attacks, and targeted attacks. Mislabeling can be error. Backdoor attack, purposeful, right? Availability attack, answers? It's a purposeful attack, and the targeted attack is definitely that one. Then we have privacy threats. Membership, interference, attack. An attacker can determine whether a specific data point was in training set. This reveals information about the training data. So privacy threats, put it in the block of the insider threat, right? It's a privacy. I have the privilege and I can take advantage of the data available, which has been trusted to me by the company. Model inversion attacks. An attacker can reconstruct training data from model outputs. It is particularly dangerous for sensitive data like medical records or financial information. Then we have privacy leakage. That means, again, AI, privacy leakage. What is the private? The biggest asset is the language model, right? Language model and embeddings can expose training data through their outputs. We have seen cases when LLMs have regulated entire passages from the training data, including personal information. So insider threat is the biggest challenge a company faces. You can still be safe from outer, but it's very difficult to find the insiders. I'm repeating again, privacy threats. There are 3 kinds of privacy threats: membership interference attacks, model inversion attacks, and privacy leakage. Then we have data quality issues, which is the bias in data, skewed representation cause unfair predictions. Hiring AI trained on based historical data will perpetuate discrimination, concept drift. The distribution of data changes over time. A model trained in historical data may not perform well on new data, right? Again, it's learning. It's not it cannot it lacks human intelligence. So that's why the concept drift happens. Then the I already discussed the bias of data, right? Yeah. So now let's take an example. Okay. Healthcare, a poison medical imaging data set, just like X-ray. So AI is systematically misidentifying critical conditions. The attack was subtle. Only 5% of the training data was poison, but it was strategically chosen to cause specific misdiagnosis. The model maintained high overall accuracy, so the attack went undetected for months. Now, this can be critical because in real time patients are getting diagnosed incorrectly because we are using the AI model. Can we stop using the AI model? The answer is no, because it is useful, it is handy, it is making our lives easy and simple. So the usage is not going to go down, but yes, we need to just become outsmart the attackers. So data is the foundation of AI. Poison the data and you poison the model. Clear? I hope it is making sense, and we can move to the next slide, please. Thank you. We have understood the model threats. Now, how can we make ourselves robust? I think that's the next question that comes in our head. Once the model is trained, it faces different set of threats. These are model level attacks, adversarial attacks. The first one is the adversarial attacks. Four kinds. FGSM, fast gradient sign method. This is simple one-step attack. You calculate the gradient of the loss with respect to the input, and then you move in the direction that increases the loss. The result is
या तुम लोग कैश लो काम खत्म कर दो मैं तो ये सारे हम कभी रहते नहीं इसलिए
Proceed, madam, please.
Yeah. So fast gradient sign method, again, this is a simple one-step attack. You calculate the gradient of the loss with respect to the input, and then you move in the direction which basically is an incremental. You check it in the incremental way. So the result is going to be perturbation that tools the model. Then comes the projected gradient descent. Fast gradient, projected gradient. There is an iterative version of FGSM. It's more powerful and harder to defend against. It's also more computationally expensive. CNW, that's the third one, which is Cartanian Wagner. This is an optimization-based attack that's highly effective. It's fine in the minimal perturbation needed to fool the model. It's considered one of the strongest adversarial attacks. I hope these three are clear. The scary part is the attacks transfer. An adversarial example created a fool. One model often fools other models trained on the same task. This is called transferability. So these terms we are learning as well. These are very new for us again. This world is changing every single day. Now, I would like to give you an example for this, the scenario. So the certain researchers, they created adversarial patches, physical stickers that could be placed on objects to fool computer vision systems. A stop sign with a small patch could be misclassified as a speed limit sign. An autonomous vehicle relying on this computer vision system could make dangerous decisions, right? So things are at large right now with the AI. We are learning from our mistakes, and attackers are learning faster than us, but we have to keep the pace. Now, model extraction attacks are another serious attack. Attacker queries a deployed modern API and learns its behavior through the outputs. With enough queries, sometimes 2,000, 5,000 query, attacker can create surrogate model that approximates the original with 90 plus fidelity. This enables IP theft. Competitors can replicate proprietary models and commercialize them without permission. Right? So the model extraction attack is, I think it is going to be the most common attack, I should say, considering the kind of competition we are facing. Backdoor attacks are particularly insidious. Trojan trigger in the training data. Model behaves normally except when it encounters a trigger. The model maintains high accuracy on clean data while harboring a hidden vulnerability. These can be introduced during model development or through compromised dependencies. The key message here is models are not static. They can be attacked in production, in the training mode, while they are going in production, while they're in training. These attacks are often difficult to detect. Okay, next slide, please. Deployment and operational threats. No, the slide is correct. So now let's talk about the deployment and operational threats. These are often overlooked, but they are critical. Deployment level, just now I mentioned that if the model is in training and then we have to deploy it, this is that level threat where the infrastructure gets compromised. They're using cloud services, and the device can be compromised. Code injection, right? In which the attackers can actually inject some malicious code into processing pipelines, and they can just disrupt the entire model, the training. Model weight manipulation. Attackers can actually modify model weights to change behavior. Dependency vulnerabilities, which means open source libraries with vulnerabilities affect downstream systems. Then insecure configuration. Default configuration often leaves systems exposed. Exposed APIs, machine learning service endpoints without proper authentication leak sensitive data. You are exposed. The company is exposed. So deployment level threats, again, infrastructure, compromise, code injection, model weight manipulation, dependency vulnerability, insecure configuration if you're not planning it ahead. and the exposed APIs. Then we have operational level threats. Insufficient access controls. Now this is the most common reason for the threats, when there is no access control in the organization. Like not a demeanor, but if somebody is protecting your entrance of the office, I cannot give him the key of the CEO's room and say that my office is safe, right? There is a hierarchy who has access to what information. So if the access is not controlled, who can access the model, who can modify it, you're exposing yourself to bigger threat. Because not that I'm not saying every time insider threat happens. Sometimes the people with the low sometimes the people with low access rights, they get hacked, and if they have the privileges, they can be catastrophic for the company. Inadequate monitoring. Are you detecting attacks in real time? Poor incident response. Do you have procedures to respond to security incidents? And then we have insider threats. Malicious or negligent employees can compromise systems. And weak change management. How do you ensure changes don't introduce vulnerability? Right? Now we have supply chain risks. We already covered that. The supply chain. Now we are going to see how can that be a risk. Compromised open source libraries affect all downstream users. There can be malicious packages upload to package repositories. Like I gave you the example, our supplier has been compromised. They have malware attack, and the malware attack is being sent to all the customers. And we are connected through an API. The API catches the infection and can forward to our system. So translated dependency create complex attack surfaces, and unmaintained libraries accumulative vulnerabilities over time. I am not sure if we are aware about the company called SolarWinds. It was like an epic when it comes to this kind of supply chain attack. SolarWinds was attacked by a single compromised dependency. In the AI space, we have seen similar attacks where malicious machine learning libraries were uploaded to PyPy. Developers who install these libraries unknowingly compromise their systems. So security doesn't end at the model, it extends to infrastructure operations and supply chain. You see how the security needs to be prevalent in every phase, every area or sector of work in an organization. Next slide, please. This is quite a big topic. We need to clearly understand the domain-specific threats. So there are various AI domains, and they all have different threats as a challenge. Let me walk you through the major ones here. Natural language processing threats. We all know natural language processing. I'm guessing we all know natural language processing. So prompt injection, malicious inputs that manipulate LLM behavior. An attacker can craft prompts that cause the models to ignore its instructions. Jailbreaking, bypassing safety guardrails. we have seen cases where researchers found prompts that caused ChatGPT to generate harmful content. Privacy leaks. Language models can expose training data through their outputs. We have seen LLMs resurfacing entire passages from their training data. And then bias and fairness. Language models can perpetuate and amplify biases in training data. So these are very minute and high level threats. And again, protection against them is a little bit tricky and much more granular. Then we have computer vision threats. There we have adversarial examples. That means imperceptible that can actually fool the models. Then we have physical patches, real world adversarial patterns on objects. Deep fakes, synthetic media that can fool detection systems. We all must have heard about that classic case where a CFO called it was a video call, and he asked and he actually persuaded the employee that he is a CFO and got some, I don't know, 25, 35 million of dollars transferred. And it was deep fake. It was someone else, just the face was looking of a CFO. Facial recognition bias, right? And then evasion attacks, objects designed to evade detection. Reinforcement learning threads. Reward hacking. Agents finding unintended solutions to maximum rewards. Adversarial policies. Policies designed to policies designed to fool other agents. Safety and alignment. Agents misalign with intended objectives and poison rewards. Corrupted reward signals during training. So each AI domain has unique vulnerability that require domain-specific defenses. Any questions for me?
Any question, participants?
I hope it's not boring and it's making sense, like you're taking some notes from here. These are not the things of the future. They are the things which are happening right now and of real world, these are real world scenarios. Okay, so the next one is the defense strategies. How can we defend ourselves? How do we build secure AI systems? So we have covered a lot of things about the threats, right? How about we discuss about how to protect ourselves? A multi-level defense strategy that mirrors the threat model. So level 1 is going to be the data level defense. The first one we discussed was the data level threat. Now the data level defense. Data validation at integrity checks. The same old verification model. Verify the data is what you expect it to be. When we were young, our parents used to teach us, proofread, and then submit the paper to the teacher after the exam. Same thing. We have to revalidate. We need to be checking the codes. We need to check that everything is as it is expected to be from the original code or original model that was written. Access controls and authorization. Who can access the training data? Right? Anomaly detection. Detect unusual patterns in training data that might indicate poisoning. Saying is easy, difficult to do. Trust me on that. Differential privacy. add noise to training data to protect individual privacy. Version control, track changes to training data. Level 2 is the model level defenses. Adversarial training, train the model on adversarial examples to make it more robust. The only thing we can do is to keep training the data in such a way that it becomes difficult for it to, for a lot of wrong information to be, ingested. Defensive distillation is use a teacher model to create a more robust student model. This is very effective. Little complex, but it is more effective. Then we have certified defenses. Provide formal guarantee on robustness. Ensemble methods. We do not have enough time to cover all the things in detail, so I'm just letting you go through it, understand the words and the significance. Then ensemble methods, which is combine multiple models or for better robustness, and then robustness testing. Systematically test the model against known attack. So we have covered data level defenses, model level defenses. Now we have deployment level defenses. Secure your coding practice. Write the code in such a way that it resists the injection attack. Input validation and sanitization are must. Validate that the inputs before processing. Nothing goes before proofreading. Then we have to containerize and isolate the model from the rest of the system, so that we are basically saving ourselves from lot of trouble if we are doing this kind of containerization. Then we have encryption. We did encrypt the data. Amazing way to protect ourselves. We encrypt data in transit and at rest. I think this is the best strategy, but again, a lot of work goes into it. Access control, the very first step, the very first way where we protect our data. We have our guards covering the door, wall, window, upper wall, and so there's no attack coming. So we are not leaving any open holes for anyone to enter. This covers the deployment level defenses. Then we have operational level defenses, right? Operations means human involvement. Now, comprehensive monitoring. Monitor the model for anomalous behavior, incident response procedures. Have a plan to respond to security incidents. Security audits. Regularly audit the system for vulnerability and security awareness training. Train all team members on security. I think companies fail to do that. Trust me, people make such silly mistakes. They still have the passwords written on the notepad. They still have passwords. They share the screen and they share the passwords. So the security audit. All these things needs to be kept in mind. Was I muted by mistake? Do you want me to take a pause? I was muted. Was it like by mistake or am I audible?
Madam, audible. You are audible, madam.
Okay. So we have covered operational level. Now let's go to the secure development lifecycle. Now, design phase, conduct threat modeling, define security requirements, design defense in depth. The designing phase is the critical phase. sometimes I honestly feel that I reach out to the, to the project planning and all those departments and tell them that make cybersecurity as a part of the SDLC life cycle, because we are missing on it. So the design phase is where the security check needs to be identified and suggested. Then the development phase. Use secure coding practice, conduct static analysis, and always perform code reviews. That's must that a coder should do. Then we have testing phase. That means the tester, they need to do the penetration testing judicially. They have to do the security testing. They do have to do the adversarial training testing. Deployment phase, we make sure, sorry, they have to make sure that the configuration is secure. The access control again comes in the picture, and the monitoring setup is there. Maintenance phase, patch management, continuous monitoring, incident response. Key message, security must be built in from the beginning, not added later. The more we are securing ourselves, the better it is. This needs to be the motto and the way forward. Any questions? If no questions, let's move to the next slide, please. Thank you. So now how are we going to regulate our landscape and compliance? Right? So when it comes to security, let me talk about a bit about the compliance. When it comes to security, the organizations, the countries, they all are aware about, they all have been aware about that there has to be certain checks in place. Compliance comes from there. Every industry has their own compliance, right? Like health sector has HIPAA. I am not sure how forceful or how impactful it is in India yet, but yes, it is there. Any company which is keeping the important information of the customer, like the credit card information, they have to have the PCI DSS. Any company which is there is ISO 27001, which actually applies to many companies, pharma, production, also the banking, right? They all have to follow these kind of compliances. How it is impacting AI and how we are arming ourselves against the attacks. AI becomes more powerful. Regulations is catching up. There are now several major regulatory frameworks that organizations need to comply with. I have included some examples from the EU and US acts. So we don't really have to go in depth, but I'll just brush through them. So the EU AI Act, it says that it requires transparency and explainability for high-risk AI systems. It requires fairness and bias assessment. It requires accountability and audit trails. AI system needs risk categories classified. Human oversight for high-risk systems should not be. So there should not be any human oversight. And if there is any business impact, there is a fine of 6% of global revenue. So you know what? There are acts which are coming in place. They're still forming, but some of them are still in place, and they're just trying to be holistic, because companies try to save money by not applying or implying. Therefore, if they're found guilty, there are fines on them. They might not be in the business again, right? NIST AI Risk Management Framework. It provides structural approach to managing AI risk. It focuses on governance, risk assessment, monitoring and testing. Recommended for US federal agencies and contractors, increasingly adopted by private sector organizations. And the impact is compliance requirement for federal contracts. Then we have US executive order. Focuses on safety and security standards. It emphasizes responsibility AI development. And I would not like to mention many of these because, again, it might not be of relevance for us. But if you really need to know more about it, I can share something for the Indian AI Act as well. But let me move further. It's the challenge that we face with the compliance. The balancing act, that is the security and performance trade-off, require careful optimization. As you have seen, the challenge is actually very, very minimal. It's not easy to detect. So the act between security and performance has to be very skillful, and skilled labors are needed in this industry, right? Jobs, future, security, money, monetary benefits, everything is there. It's just that we need to sharpen ourselves and be more usable for the industry. Now, again, another challenge for the compliance is the documentation. Documentation means extensive audit trails and compliance records required. Cross-border regulation across jurisdictions, because the companies are international. So we have to keep that in mind, that the company you are trading with, you follow their guidelines, the acts that they have in place, the security requirement they have. That needs to be that is going to be crucial. Then we have emerging standards, regulations which evolve faster than industry can adapt. Resource intensive, tremendously resource intensive. It requires a lot of investment. You need to have the tools to store the data, to store the documentation. People continuously working on it, upgrading it, informing the employees. There should be a proper channel flow, the flow of information that needs to be maintained. So it is a very resource intensive work in any organization, but a must. Then we have sector specific. As I already have mentioned, that we have HIPAA, we have PCI DSS, we have ISO, and multiple such compliance requirements. What I can say about the regulation and compliance is that it is becoming mandatory. Organization needs to start preparing now. This will need a lot of lawyers as well, because the compliance part and regulation part, it's basically lawyers who specialize in these acts. So companies need that professional expertise to maintain their security. Okay. Then we are moving to emerging threats and future challenges. Thank you. The threat landscape is constantly evolving, and some emerging threats that should be in your radar is deepfake and synthetic media. Generative models can create highly realistic synthetic images and videos. they can detect systems are struggling to keep up, and they are implication, which is like misinformation, fraud, identity theft, social manipulation. Pretty much spreading everywhere and is becoming smarter day by day. It's kind of difficult to identify whether it's actually a deep fake or not. Many a times we are getting calls that your laptop is not secure, you have an attack, or we are calling from the bank. And trust me, that's not the human being that is at the other side. It's the robotic voice, which is sounding very much human. So the deepfakes and the synthetic media is actually becoming a threat for the common people, not just for the industries and companies. Supply chain attacks, compromised dependencies, if they are going to be going to impact the downstream users. We have seen in the SolarWinds, we have seen in the Target. Target is a company in US, a big chain which was actually taken over by Amazon, but they're they have been compromised because of the supply chain attack. So it is not easy to trace and remediate because you are not in the direct attack. You are a victim, and it becomes very difficult for to control that kind of attack and get rid of them. So the implication is widespread vulnerability. One attack can compromise thousands of systems. Quantum computing threats. Future quantum computers will break current cryptographic protections. Post-quantum cryptography adoption is urgent. Implications, legacy systems at risk. Need to migrate to quantum-resistant algorithm. A must. Quantum is going to be the future. And the way it is helping in training the AI model is amazing. GPUs are actually lagging because of the quantum computing. So if you talk about the not even far-fetched future, immediate future, we are talking about quantum computing. Then we have federated learning vulnerabilities, means we have the training introduces new poisoning and privacy vulnerabilities, as we discussed above. We have individual nodes which are getting impacted because of the data poisoning. We have communication deception, aggregation attacks, and privacy and security challenges in distribution systems. AI alignment and safety, ensuring AI systems behave as intended, preventing autonomous system failures. Implications are existential because of this AI alignment and safety. If we are not protecting our AI, we are at the risk of existential our existence can be at risk. Is that what I'm trying to say here? Because AI system behave, it is a trained program, right? If it is not behaving in a certain fashion, it can be very risky. We are expecting to have robots at home in a couple of years. So again, it has to stay safe. So security in the AI is going to be very critical and a thing of the future. And I guess a new stream of career which doesn't really exist even now. So we are preparing for many new jobs, many new roles that does not exist, and many new roles are going to be scratched out in the coming couple of years. We have to have the research frontiers. Why? Because of the certified robustness. We have the format that guarantees on adversarial robustness, and intelligent people are actually writing all these things before it is implemented. At the end of the day, it is a program, right? Explainability and interpretability. So understanding AI decision making. It is becoming smart. It is becoming smart, auto smart. A few, I think in the previous one, I mentioned about the human intelligence. Why are we smart? Like we use the word, I'm sorry, I'm using the word jugaad because we do use a lot of brainstorming. We come out of the situations. So right now, AI has not reached that level. AI still follows the rules, but in certain iterations, they have figured out that one AI is teaching the other AI. They are talking, and they became so smart that they actually had to kill the program. They had to kill the entire project. It happened in Alphabet. So, if I have to put that, we have seen many sci-fi where, you know, AI has started attacking us, taking us as the source of energy. Might this come true? Sorry, I'm scaring. No. We are aware about the challenges, and measures are in place. Coming back to the security perspective, we have to have something in place, which is AI, whatever decision AI is making, it should make sense, and it should be researched, and it should be recorded. Fairness and bias mitigation. So that means as a researcher, I cannot favor one particular behavior. It has to be, your prudence needs to be used. You need to be fair when you are writing a code or providing such information. So the threat landscape is rapidly evolving. We need continuous research and innovation to stay ahead, and documentation of everything that we are doing. Any questions for me until here? Next slide, please. No, I'm sorry. Can you go back to the above slide? Can you go back? I'm going to share a slide, a separate slide with you, Dr. Vineet, and you can share it with the participants. Let me just conclude certain things over here. How can we build security culture and roadmap? We can, so how can we implement these defenses that we have discussed, right? Because theory is theory, but then how are we doing it in practical? So the very first thing that comes in an organization that we need to understand is going to be the shared responsibility. If a company is not applying security as an organizational base, or for the entire organization, that company is not going to be secure. You have a company needs to apply it at the developer side. It has to apply at the data scientists, operations teams. Everyone has a role to play. We cannot just say that it's only the cybersecurity team who has to look for the cybersecurity. No. If I am logging in any organization, my access needs to be secure. I need to follow the protocols. I need to rotate my passwords in couple of days, couple of months, as per the policy. There has to be phishing attacks, internal phishing attacks. Data needs to be, there should be red teaming, purple teaming, blue teaming, and there should be rigorous test of the data. Depends on the organization, of course. If I am a small store, I am not investing in all these things. But if I'm running a unit which is making a life-saving drug, I want to protect my formula. I want to make sure that I am not attacked. I want to make sure that my medicine composition is not being changed. And it is, rather than giving life, it can become a threat to the patients. So yes, it has to be a shared responsibility. Then what an organization needs to do is to have the executive commitment. Leadership must prioritize and fund security. Most of the time, CFOs or CISOs, they don't give fund for the security team. They think it is the leftover should be given to the security. Thankfully, the mindset is changing. Thankfully, they're allocating more fund for the security because there are multiple tools, multiple trained people who come very expensive. They have to have that kind of commitment, and they have to have that kind of investment ability in these safety protocols. Then comes security awareness. That means training the team members, telling them that do not click on the phishing email because you can actually spread malware in your organization. Few months back, there was Mark and Spencer. They got attacked. It was a phishing attack, but it was not um, an innocent attack. Basically, one employee, he got the email as a portraying as a phishing email, and he clicked the link, and he basically sprayed the malware in the organization. This year they had no profit. Their profit is equal to last year because all the profits were gone for the cyber attack. And that's how the companies are facing the losses, and they find themselves helpless because I think they didn't even have this insurance. Then we have incident readiness. That means prepare for the inevitable. Have procedures in place to respond to security incidents. I just mentioned the red team, blue team, purple team, which means the people who are doing the pen testing, the continuous rigorous test, that if I am an attacker, I'm attacking the company, I'm trying to access password, employees, phishing, everything is right. I am doing it. Employees are aware. There is no, my EDRs are in place and they are detecting password, multiple password attempts. I'm safe. Company is safe. When I say I mean the company. The company has to think from that perspective. And then the continuous improvement, learn from incidents and evolve your defenses. Security is not one-time project. It's an ongoing process. I'm kind of done. There has been not many questions during the discussion. So I would just like to summarize it that AI security is critical and urgent. It's the real need for the day. It's not in some distant future, right? Organizations are being attacked right now. We have the existing threat at multiple levels: data, model, deployment, supply chain, operational. We have to have defense at all levels, as we discussed, how we can apply the security at different threat level. Security must be built in from design, not added later. It should be imbibed when the program is written, when the model is being created, when somebody is cross-checking it. There should be a point how the security needs to be followed or checked. And then collaboration across all the academy and industry, coming back to the main point that our education system, we need to develop this kind of thought process amongst our students, how critical the security is. It's not, you cannot ignore it. Like we lock our doors when we leave our house or lock our cars. Same way, we have to ensure that organizations are safe and organizations are taking care of it. We need key caretakers. We need people who can take care of the company's security. Same way. So if we have faculty here, for faculty, the takeaway is going to be that integrate AI security in your curriculum, please. Any challenges in studying? There are materials available, trainings available. You need help, you can reach out to me. Establish partnership with industry, like get the real-time problems, conduct applied security research, and mentor the next generation of security experts. For the practitioners, please implement defense strategies now. That's what needs to be conveyed. Don't wait for breach to take action. They need to conduct security assessments of AI system, understand the vulnerability, stay updated on emerging threats, subscribe to security bulletins, follow research, attend conferences. Share lessons learned with peers. The security community benefits from shared knowledge. It's such an open community that nobody wants to hide anything. Even if people make mistake, they do podcast and they say that mistake they did, so the others get benefited. So this industry is a very open industry, very welcoming, very open. People need to understand, and it should be a part of the growth part. All the fellow researchers, please advance your adversarial robustness. We definitely need stronger defenses against adversarial attacks. Please try to develop certified defenses that have, again, robustness in place, and study the attack vectors. There are new threats which are constantly emerging, and we need to understand them. So we need researchers to do that kind of work for us. And please publish your findings and openly publish it, so your work can be appreciated and can be brought to use. My say for the path forward is the security of future of to secure AI system depends on the collaboration between academy and industry. By sharing knowledge, builds partnerships and maintain vigilance. Emerging threats, we can create AI systems that are not only powerful and accurate, but also secure, trustworthy, and resilient. Time to act is now, and together we build a secure AI future. Implement incrementally, monitor continuously. Any questions for me? Sure, Madhuri. Dr. Vinay, do you want to say anything? Thank you so much. I hope I imparted some knowledge to all of you, and I wish I could have heard something from your side as well, but next time. Thank you. All the best to everybody. Take care.
Thank you so much, Suraksha Madam. Both session was very informative. In the first session, AI for Industry 4.0, highlighting with the brain of Industry 4.0, predictive maintenance with suitable graph, automated quality control, AI in action with resilient supply chains, the talent gap, curriculum shift, research focuses, slowing the 100 millions problem, collaboration models, while in the second session was full of focused with security aspects of AI with highlighting the AI security paradox, the threat landscapes, overview, data level threats, privacy, model level threats, and robustness, deployment and operational threats, domain specific threats, defense strategies, and uh, secure development, regulatory landscape, and compliance, while the emerging threats and future challenges. Suraksha madam, despite your busy schedule, you took out valuable time for us. We express our heartfelt gratitude to you with due respect, Suraksha madam. Have a nice day ahead.
Thank you. You too. Take care.
Thank you
Bye.
so much.
Thank you, dear all participants. Have a nice day. Good night.